In this video lecture series, particularly, I am going to explain about the basics of digital modulation techniques. Whereas first we'll see about the digital to analog conversion. It is nothing but the process of changing one of the characteristics of an analog signal based on the information in the digital data. So we'll be seeing the types of digital modulation techniques in this video. There are various types. First one is amplitude shift keying, the next is a frequency shift keying, and next one is a phase shift keying. Will be call it as a binary phase shift keying, and next one is QAM. Will also called as a QAM is nothing. QAM is nothing but a quadrature amplitude modulation. So normally this is the data where it converts the digital data to analog data, and finally the analog data to the digital data by using the transmission channel. Why we need of a digital modulation? Digital modulation is required if the digital data has to be transmitted over a medium that allows analog transmission. Modem and wired networks, wireless must use analog sine waves. These are the types of digital to analog conversion. Whereas finally the amplitude and the phase shift keying will be called it as a quadrature amplitude modulation. These are the modulation and demodulation diagram. Basically, we are first giving the input data to the baseband modulation, and it is given to the carrier, then to the radio channel, then to the carrier, and to the synchronization or detection, and finally to the output, and will receive the output data. These are the various modulation techniques, and the representations are shown are displayed here. Whereas in phase shift keying, it modulates the phase of the carrier. In frequency, it modulates the frequency of the carrier. In ASK, it modulates the amplitude of the carrier. Modulation, the process of translation the baseband message signal into the bandpass signal at frequencies that are very high compared to the baseband frequencies. Then in demodulation, it is the process of extracting the baseband message back to the modulated carrier. An information bearing signal is non-deterministic, that is, it changes in an unpredictable manner. ASK, where ASK is nothing but a pulse shaping signal which can be employed to remove spectral spreading. ASK demonstrates poor performance as it is heavily affected by noise, fading, and the interference. The pros and cons of this ASK is, that is, advantages and disadvantages are: ASK transmitter and receiver are simple to design. ASK needs less bandwidth than FSK, where ASK transmission can be easily corrected by noise. The main applications are early telephone modem, and this is used to transmit digital data over the optical fiber. Frequency shift keying baseband data, and binary frequency shifting modulated signal. Example is modem standard uses FSK. This FSK can be expanded to a MRA scheme which employs multiple frequencies at different states. The frequency of the carrier signal is varied to represent the binary 1 or 0. Both the peak amplitude and the phase remain constant while the frequency changes. The frequency of the signal during each bit duration is constant, and its value depends on the bit 0 or 1. The difference between ASK and FSK is nothing but amplitude shift keying is very simple to design, whereas FSK needs larger bandwidth, and it also has low bandwidth requirements. It is more resilience than AM. It is very susceptible to interference. Phase shift keying. The phase of the carrier is varied to represent two or more different signal elements. Both peak amplitude and the frequency remains constant. Whereas in BPSK we have only two signal elements, one with a phase of 0 and the other with a phase of 180 degree. These, when compare this phase shift keying with the ASK, PSK is more complex and it is robust against the interference. So this is the digital modulation summary. First one will be called it as a ASK, next one is FSK, and third one is a PSK. Whereas the amplitude changes, amplitude remains 0 in case of amplitude shift keying. Whereas in case of frequency, the frequency is getting varied when compared with 1 and 0. Whereas in case of phase shift keying, the signal is tilted for 1 and 0. Thank you.